Yeah, yeah,
We just
that is
installed the
correct.
Docker, and after installing the Docker, we have seen the network configuration, how Docker can be configured, and what are the different network configurations that we have, like default network configuration. And then we went through certain configurations like what I can say. We have went through certain configurations like difference between like user bridge whenever the user is so whenever the user is creating the Docker network, so he can configure the network bridge, and that network bridge can be automatically configuring the DNS. So this is what we have seen, if I am not wrong. So today we will be discussing about a new topic in Docker itself. Okay, so that topic is that before we go into that topic, let me explain you about the Docker architecture and Docker life cycle or container life cycle. So we are going to discuss about container life cycle. So everyone will call it as a Docker life cycle. Actually, in Docker doesn't have any life cycle, guys. So for an application, what will be there? So inside that application, whatever the processes that are running, that process will have the life cycle. Okay, so here also we need to understand the container life cycle. So what is this container life cycle and how we are going to create this container life cycle? So now if you can see here, let me go back to my AWS and launch the instance. Already we have a Docker instance which is created. Let me go ahead and start that and configure that images. Hmm. So let me go to the EC2. In EC2, we already have a Docker instance that is created. Last session, I have created this Docker instance. I just stopped it. So let me start it again. So once the virtual machine is started, then we can access this, and let me deploy a container in that. Hold on. Now what I will do here is let me copy the public IP, and I will go back to my uh, Ubuntu at the rate and provide the IP address over here so that we can access the server. So inside the server, we already have the Docker running. So yesterday we have installed the Docker. So sudo su hyphen. So guys, one more thing what you need to understand here is uh, the point is whenever we are running the Docker, so in the company, whenever you go inside the company won't allow you to access the root user. But here we are using the root user. Try to understand the scenario here. So if the company is not providing you the root access, then how you will access it? For example, the company will create a user account for you. Let me create a user account for you. User add hyphen m. Okay, user add hyphen m Chaitanya. Okay, this is the user which I am adding, and I will set a password for this user also. Password Chaitanya. If I create this, now whenever I am creating this user, you will be logging into this user only. Okay. Uh, I will be logging into the user account. Okay. Now the password has been successfully changed. If I go to su hyphen Chaitanya, then I will go with the bash. Okay. Good. So now what I can do, if I go for Docker PS, it is going to throw me an error. So what is the error? Permission denied. So I don't have the permission. Why? Because this particular Docker was installed by the root user. If you remember, the Docker was installed by the root user. When Docker is installed by the root user, the other users cannot access that Docker. Now, how I can make the other users to access the Docker? So to make the other users accessibility, now what I will do here is user mod -a -g. What I will do here is I will add the user Docker and Chaitanya, which means that whenever the Docker is created with the Docker, we will have the Docker group created. So now what is happening here? So I am adding Chaitanya to the Docker group. Whenever I have added Chaitanya to the Docker group, now this time, whenever I log into Chaitanya, now what happens here? Look at that. Docker PS. Now here you can see Chaitanya is also capable of accessing the Docker configurations. Or else if I go with the Docker images, now I am able to get the images. And if I see here Docker PS-A, so whatever the containers that are exited or stopped, all the containers are shown here. Now what I can do, Docker RM or else Docker RM $, Docker ps-aq. When I give this command, what is the meaning of this command is Docker ps-aq means it is going to give me all the container IDs. So what is the exact meaning of this command? The command will display the, you see here, the command will display the container IDs. So we are going to remove all the container IDs with the help of Docker RM. So let me show you Docker RM $docker ps-aq. When I give this command, automatically all the containers will be removed. So if you can see here, Docker ps-a, Docker ps-a, there is no container. So previously we have an exited containers, which means shutdown containers are there. Right now we don't have any sort of containers. Okay. So now we have created the, now we have removed all the containers. Now I want to reclaim the space. If at all, if there are any trashes of containers, or else if there are anything like images are there, any trash amount of images are there, I want to clean out that. So to clean that, what I can do here is Docker system clone -a-f. The meaning is I am forcefully removing all the contents of the Docker. See here, it is deleting the networks, it is deleting the images, and totally 77.86 MB of storage space was reclaimed, which means that it is going to delete everything. The user created whatever the networks are there, it is deleting those networks, and if there are any images, it is going to delete those images also. So now this is what system peon. Now if you can see Docker images, there is no image residing. So if you can see, there is no image here. And as well as if you go to the Docker network ls, if I give this command, now there are no networks, no user created networks, only the default networks are available. So it's a very dangerous command. Be cautious whenever you are creating, or else whenever you are running that command. Okay, now it is done. Now next what I will do here is, for example, Docker lifecycle, how you can create a Docker lifecycle. So for that, what I will do here is, first of all, whenever we are working with the Docker container lifecycle, now first one is we will create the container. So right now what we are doing, Docker run command we are using. So now what I will do here is, here I will use a create command. So when I click on, or else when I execute the create command, Docker will create a container. Docker will create a container, only creating of the container. It is not going to be in the running state. So now what I will do, let me go back here. Docker create, okay, -it, or else you can give simply directly name also, --name, test container, and with the image Ubuntu. Okay, so now we have created a container. So now if you can see here, Docker PS. So Docker PS will execute only the running containers. Here you can see there is no container. So Docker PS is a command. So guys, write it down. Keep a rough notes besides you. Maybe sometimes video recordings might be delayed or else might be problematic, or else what I can say you, if you write it down, it will be very helpful for you whenever we are working with the next. If every time you cannot open the videos and you cannot check it out right in your office. So my recommendation is that keep a rough notes besides you, rough notes or rough papers besides you, write down each and every command, which is very helpful for you whenever you go into your company. So inside the company, you can utilize your notes and you can check out that whatever the commands that we have executed. So please make it a note of that. Or else if you want to, it's not a recommended thing to store in the notepad also. If you store in the notepad, it might be deleted. So write it down in a notes so that you will have a clear-cut knowledge. Okay. Now here, Docker PS. What is Docker PS? Docker PS is a command which will be executed to know what are the running containers. Running containers. Be very precise about running, which means that which are already started and they are in the action. So that containers will be displayed with the help of Docker PS command. Now when I give Docker PS -a, now here you can see it is going to display all the containers, whether the running containers or shutdown containers or created containers. Every containers will be displayed in this with this command. What is the command? Docker PS -a. Now here you can see a container is, what is the status? The status is created. It is created, not yet started. Now when I start the container, now the container is created. Now when I start, when I pass the command Docker start, when I pass the command Docker start, the container will be started. Which means it will be coming into the running state. So if I pass the command Docker start. Okay, Docker start. Now if you can see here, let me show you Docker start. What is the container ID? The container ID is this. Let me give the container ID. Or also you can provide the container name also, test container. Now the container is started, Docker PS. So it might be exited. Now let me go back here. See that it is exited. Now what I will do here is, let me remove this container, Docker RM. I will provide the container ID. Why it is exited, I know. Hold on. Is my screen visible to you? Okay. Now what I will do, actually why it is exited, I know. So now at the time of creating, what I will have to do here is Docker create -it. This is not which I have provided. Interactive terminal I have not given. So that's the reason it is exited. -it -name. Again, test container and Ubuntu. Ubuntu. When I give this, now here you can see Docker PS -a. Whenever I give this command, a container is created. When a container is created and running, now what I can do here is I can start the container. Docker start. I will provide the container ID, or else you can give the container name also, guys. If at all, if you have the doubt, Docker container. So here you can see Docker PS. Now the container is in running state. Previously, the container is stopped and exited. Whenever I started the container, automatically it is exited. Now it is running. Why? Because I have given that interactive terminal -it. The user should interact with the container. So that's the reason it is still running. Okay, with this command, what is the command? Bin bash. So this command will be continuously running in the background. So what is this command? I will tell you within a small time. Hold on. Now the container is started and it is running. Now when it is running, or else I can directly do one more thing also. What I can do here is, without these two steps, what are the steps that we have followed? Without creating and starting, directly I can make the container into running state. Directly I can make the container into the running state. How I can make the container into the running state? By executing a command docker run, or else I will use a command called as docker run. With the help of that docker run command, I can directly make a container to run. So see here, docker run hyphen itd in the sense hyphen it in the sense interactive terminal. So the user has to log in into the Docker container using the terminal. So every time whenever we are logging into the terminal, what is the command that we used to use? So that is docker exec hyphen it, which means that I just need to log in. A terminal has to be created for the session into this container. So what is the container? Any container name. Okay. Container name, and you have to give bash, or else you can give sh also. So depending on the operating system, if you are using Ubuntu, you have to go for bash. If the environment or else the container is created with the help of Red Hat Linux, you can go with bash. Or else if it is created with Alpine Linux, then you have to go with sh. Depending on the operating system, you have to select either bash or sh. Or else depending on the environment through which the container is created, you have to go with bash or sh. Now, let me go to docker run hyphen it. D in the sense the container should be in the detached mode. It should be running in the background. So whenever the user wants to log in into the container, he can log in. Or else if he don't want to log in, or else the container has to be running in the background continuously, then I can use the D. D means detached. Okay, hyphen name. The name of the container is test container 2. Okay, I will provide test container 2, and with the same image, that is Ubuntu. When I provide this, automatically Docker PS. Previously it is in the running state. Now it is in the, see here, directly it is in the running state. Now the container is directly into the running state. So what happened here? Here we have skipped the two step. One is creation and the other one is starting. Directly now the container is in a running state. Now what I can do here is, for example, due to any reason, I want to take the backup. I want to take the backup of that particular running container. Now how I can take the backup? I can create an image. How to create an image, I will tell you. But as of now, what is my requirement here is, due to any certain things, any problematic situations, I want to troubleshoot the container. So I want to troubleshoot the container, or also I want to take the backup of the container. So I just want to make the container process halted. So I am talking that container process should be halted, but not stopped. There is a difference between halted and stopped, guys. Can anybody tell me what is an halted, or else is stopped, or else pause? What is the main difference between pause, stop? Yes, anyone? Can anybody explain me what is the difference between pause and stop?
So once
Was it
pause, we
holding?
can start again
Mhm,
instance. So
mhm,
if we stop the instance,
mhm. If we stop the instance will be, whatever the processes that are running on the instance will be stopped. For example, you are watching a movie. Okay, whenever you are watching a movie, suddenly your parents has asked you to do some work. Okay, when they want you to do some work, whether you will pause the movie or stop the movie. On the TV, you will pause it, and then you will go back and go to the work and complete the work and come back, and you will unpause it, which means that until then the movie will be in the pause state, which means that the process will be stopped, but in the RAM, whatever the data is there, the data will be stored as it is. So in the same manner, in the TV, at what time you have paused the movie will be stopped at that. Stopped in the sense it will be paused, and then when you resume it again, it will be starting from that point where, for example, you have watched up to 1 hour 10 seconds. So then the movie will be resumed at 1 hour 10 seconds and it will be continuing. So that is meant pause. So the processes won't be killed, but they will be halted. Okay, to troubleshoot or else to make a backup of that container, the particular uh, process will be stopped or else halted at a point, and then it will be continuously running. Okay, now stop means like if you stop the container or else if you stop if you stop watching the movie, so you have completely stopped watching the movie, again it will be starting from the again it will be started from the starting point itself, from the 0.00 minutes 0 seconds. So that is stopped, which means that the entire process will be killed and a new process will be created when you start it again. So now if you can see here, now what I can do, let me show you Docker pause. For that, I will go ahead with the Docker stats. If you can see, if I run the command Docker stats, it is going to show me test container is using 0% of CPU and 0% of the second container is also 0%. And memory utilization is 880 KB and 2.7 MB. Now what I will do here is, I will go into one of the container. Let me go into the one of the container Docker execute -it test container 2 and bash. Whenever I was logged into this container, now what I can do here is apt update -y, and then I will install a special configuration as a special component in this particular container. See here, what I will do here is sorry, apt install. It is a Ubuntu container, so I'm using the apt repository command. Okay, apt install -y stress. When I install this, oh, come on, a virtual load will be applied on the container. Now, if you can see, let me do one thing. I will go to a duplicate session. Now here you can see sudo su Chaitanya. Logging into this user. Okay, good. So now I was in the Chaitanya's user Docker stats. Right now the CPU utilization is 0% only. So now what I will do in the Docker container, if I apply stress, so if I just want to apply the stress for 10 minutes, 10 minutes. Now, previously, when you see here, the CPU utilization is 0%. Now, if you can see what is the CPU percentage of our test container, the CPU utilization percent has been increased to 90%. Now, due to some application, there is a problem. So, due to some application, there is a problem, and I want to take the backup of entire container, and then I want to troubleshoot what is the problem. So, for that, what I have to do here is I want to halt this process. I want to halt this process. For that, what I can do, I will go to a duplicate session again. Okay. So guys, I have taken 3 sessions. One is for running the stress inside the container, and the other one is for showing you how much amount of CPU utilization is happening. And then the third session is for making the commands run or else to run the commands. Okay, su-Chaitanya, and then good. So now what I can do here is look at here Docker pause, and the container name is test container 2. When I run this, when I execute this command, so automatically see that the container CPU utilization. What is the CPU utilization? CPU utilization has become 0. So I already said you when you fire the command pause, then automatically the processing utilization or else the CPU utilization will be halted. But what about the memory utilization? Here you can see still that application is residing inside the memory only. So whenever we use the command docker pause, the application won't be deleted from RAM. See, it is like whenever your computer is in sleep mode. Try to understand, whenever your computer is in sleep mode, whether the applications will be deleted or else closed. For example, you are working on a Windows or else Word application. Okay, you are writing some document, and suddenly you have got a work and you have made the Windows log. So when you close the Windows, it will be going into the sleep mode. And again, when you log in into the Windows, whether the application will be whether the application will be closed or else it will be residing at that same position. Do you understand what is my question here? When you're working on the Word document, you have made the document or else you have made certain document. Okay. And still you have to write some 25% of the document is there. Now, due to some work, you made the computer in the sleep mode. When you made the computer in the sleep mode, the processes won't be running. But what about the application? Whether the application will be closed or else it will be running as it is.
Will be running.
It will be running in the background. So you can stop. That is like a pause. When you re-log in into the computer, you can continue that. So in the same manner here also, which means that the Windows or else the Word application is stored in still in the RAM. Okay. So when you are running back or else when you are logging back, you can continue from the point. But if you shut down the computer, if you shut down the laptop or computer, the applications will be closed. Okay, the RAM will be swiped out. No RAM consumption will be there. Entire RAM will be 0. So here you can see whenever I am giving the Docker pause command, what is happening in the backend? The Docker pause command, the container is paused, which means that the process will be into 0%. But when I go back into unpause, automatically now the CPU utilization has been increased to 9700% also, which means that the application is processing. So that is how you can calculate what is a pause and unpause. So now what I can show you here, let me close this. We don't want. Okay, after 10 minutes it will be closed, no problem. Now here the point is what we have done here. At the runtime, due to any reason, if the high CPU utilization is there, due to any reason, if there is a high CPU utilization, what I can do, or else if I want to troubleshoot it, I can go for a Docker pause so that the system will be into pause state. Okay, I can execute a command called as Docker pause so that the system will be into pause state. And to run back or else to go back to the normal mode, what I can do here, I can go with the Docker unpause command. So when I go for Docker unpause command, then automatically the system will be into running state. Okay. So what is the command that I'm using here? Unpause. Here I have used pause. Okay. Now I don't want to run the container. So I want to make the container stop. So to stop the container, so stopping means shutting down the container. So here you can see what I can do. Docker, look at here. Docker stop test container 2. Look at there. What happens to the test container here? Hold on. Docker stop test container 2. When I give this command, automatically look at that. The test container has been removed, which means that it is stopped from the running state. So now what is happening here? I can go with another configuration, that is stopping the container, another lifecycle form, that is stopping the container. When I give the command Docker stop, the container will be stopped, but it is not removed. Try to understand, it is only stopped. Now what I can do, it is stop. Okay, stop. It will be into the stop state. Again, when I want to start it, I can provide a command called as Docker start. When I provide the command Docker start, it will be coming back into the start state. Okay. Now let us go back and give the command Docker start. Docker start test container 2. Look at that. It has came back. The container has been came back. So this is how you can start the containers. Now the next one is, if you want to remove the container, if you want to remove a running container, it is not possible. Docker, if I give this command, docker remove rm test container 2, it is going to throw me an error. So the test container 2 is running. So error response from the daemon cannot remove the container. Container is running. Stop the container before removing or force remove. So you have to stop the container before you remove the container. So what I have to do here, I need to go ahead with the stopping of the container. So I need to go ahead with the command called as docker stop. And then what I have to do, I have to execute a command called as remove. Okay, until I stop the container, I cannot remove the container. So it will be a removal state. Be very cautious. When you give remove, the entire container will be deleted, not stopped, not paused. Remove. So what is the command that you have to give? First of all, you have to stop the container and then you have to remove the container. So the first, let us go with the docker stop, and then we will go ahead with the docker remove. Docker stop, docker stop test container 2. Now the container is stopped. And next what I can do, docker rm test container 2. Still it is not in stopped state. Let us hold on. Now it is stopped. Now what I can do, docker remove test container 2. Now if you can see, docker ps, only one container is running. If you can see, only one container is running, and ps-a. And here also you have only one running container, that is test container. There is no test container 2. It is completely wiped out from your Docker. Now this is one of the point which you can do. And the next one is if you want to remove any container. And the next one is if you want to totally remove the running container without stopping. It is a dangerous step. If you want to do it, you can do it. But my suggestion is not do like this. So the first thing what you have to do here is you can go with the run forcefully. Oh, sorry, docker rm forcefully. So what is the command that I can use here is rm-f. If I give this command, then automatically the running container will be permanently removed. So see here we have a test container that is running. So I want to remove the container from the running state directly if I want to wipe out the container. So docker rm-f test container 2. Previously, we have an error that it is a running container, but now we are not going to get any sort of error. So I want to remove the test container forcefully. Now, if you can see here, the test container has been deleted, or else you think if it is stopped. Now let us go with docker ps-a. There is no container that is available in our Docker. So which means that the container has been directly removed. So how it is removed? Running container is removed forcefully, but this is not a good process or else good technique to remove the container. But here we have another option. So I am showing you this. This is the Docker life cycle. Okay, so however you want to start and stop it, it's totally your wish. Whether you can directly go with the run command or else you can go with the create, start and run. So or else you can go with the pause and unpausing or stop and start. That totally depends on your requirement and the container container state. Okay, so how it is working, depending on that, you have to work it out. Okay, so that's about the Docker container life cycle. Any questions here? Do you understand it totally? Any questions? Any questions? Guys, we don't have the all time. Any questions here? Do you understand the Docker life cycle? Can I go ahead with the next concept?
Yep. Yes, we can go ahead.
Okay. So now let us go with the next concept, that is Docker architecture. Now you have seen the Docker container. So you are saying that we are creating the container. How we are creating this container? You are saying that there are so many states, that is start, stop, create, run, pause and unpause. These are all the states that we are having. But how actually we are creating this container? So to create the container, or else to start the container or create the container, first of all, you need to understand the entire Docker architecture. We are all the way into the Docker. So here, let me explain you about the Docker architecture. Up to now, what we are doing, we are running certain commands, that is Docker commands we are running, which means it's a Docker CLI. So for the client to communicate with the Docker daemon, we are having a CLI, that is Docker CLI is available. So this is the client side. So like our server terminal, we are, so what is the terminal that is helpful for us to make the communication with the Docker daemon? So this is the CLI, or else client side. I can make it as a client side client. So in the client, what we can do here is we can use the command line. Either we can use the command line, or else we can go with the GUI also, GUI. Okay. So now here it is a command line, Docker CLI, where I can run the commands. And there is one more thing, that is a Docker GUI. So now in Windows, we are having Docker desktop, like that. We are having Docker GUI also. Or else I can simply call it as SDK. Okay, with the help of these things also, I can communicate with my Docker. But now we are going only with the CLI. So this is the client side. When the client fires the command, which type of commands I can fire? I can fire like Docker build, or else Docker run, and I can go ahead with the Docker create, or else any command. So if I fire any command, so on my operating system, on my server side, I will have a Docker daemon. I will have a Docker daemon. So what is the main functionality of this Docker daemon? This Docker daemon will continuously communicate with the client and the processes. Okay, so here we will have a Docker daemon. Now, what happens when the client want to create a container? When the client want to create a container, which means that he has given the command run, Docker run. So now what happens here? It will go to the images, Docker run. First of all, the container should be created with the help of the Docker images. What is a Docker image? We will see. Now here in our server, we will have a local repository to store the images. Now, so what we are doing here, Docker images. If I give this command, look at here what is happening. When I give the command Docker images, it is displaying the images that are available in the local repository. Okay, so we will have a cache, we will have a image repository locally created. When we create the Docker, automatically local repository will be created, and whatever the images are there, the images will be stored inside this local repository. So now let me remove this image also. Docker RMI, uh, Docker RMI dollar Docker images -aq. When the image is not used, the image will be removed. So if you can see Docker images, right now inside the repository, I don't have any sort of image. So now what happens here? So whenever I fire a command Docker run, I want to create a container. So now what Docker daemon will do here is it will go to the image repository, local image repository, and communicate with the local image repository asking for the images. Do you have any image? The user is requesting. So it will check with the images. Right now on our Docker images repository, local repository, we don't have any sort of images. Okay. So now what it is going to do here, if there is no image available in the local repository, now it is going to show that the image is unavailable. So I am pulling out the image from another registry. So here you will have multiple types of registries. So you will have the Docker Hub. The main registry is the Docker Hub, or else Amazon ECR and Azure ACR. These are all the image registries where we can store our images. So what are the multiple types of registries for storing the images is, the first one is Docker Hub. Primarily, Docker will communicate. By default, it will communicate with the Docker Hub itself. So it will go to the Docker Hub. This is one of the registry. So here also, here we can store the images. Docker Hub. Docker Hub, where we can store our images in the repositories. So here Ubuntu repository, inside the Ubuntu repository, we can store the multiple versions of the images. Here, for example, Ubuntu version 1, Ubuntu version 2, like that I can create multiple images. So this is the repository. This is the remote repository where I can create uh, multiple images, multiple versions of the images. So now it is called as a repository, guys. Try to understand. There is a difference between repo. It's a repository. Inside the repository, we are creating the versions. It is a registry. Registry is like storing all the images. So not only single Ubuntu, in this registry, I can have the Nginx image. In this, I can have the Alpine image. In this, I can have the Java images, like that. Whatever the images that I want, all the images are available in the Docker Hub. Not only Docker Hub, we are having one more registry, that is Amazon ECR, Elastic Container Registry. Okay, for example, if I want to store my Amazon images, we will go ahead with the Amazon ECR in the upcoming time whenever we are discussing about the Kubernetes. Amazon ECR is available. And there is one more registry is Azure ACR, Azure Container Registry. Here we are having Azure ACR. And for GCP also we have another registry, Azure ACR. Okay, like that we can go ahead with the multiple registries. Among that, the default registry to which the Docker will communicate is Docker Hub. Now here what happens whenever the user wants to create a container. So first of all, the Docker daemon will communicate with the Docker images. Whether do you have that images in your local repo. So if the local repo or local registry doesn't have the images, then directly what happens here is the Docker daemon will communicate with the Docker daemon will communicate with the Docker Hub. The Docker daemon will communicate with the Docker Hub. Docker Hub registry. It will communicate with the Docker Hub registry and search for the images. So here you will have some millions and millions of images are available. So among this Docker Hub, it will pull out the images whatever the user is requesting. So this is how your images will be available inside your Docker Hub. Now what is going to happen? So if the user required image is not available in the local repository, it will communicate with the Docker Hub registry and pull out the image from the Docker Hub registry and stores in the local repository. So it is going to pull out that image and it will store in our local repository or registry here in our Docker images registry. Okay, like this, with the help of this image, we are the Docker daemon is going to create the container. So with the help of this image, it is going to create the containers. Okay. We will have a container created. This is my test container which we have created right now. So with the help of this image from the Docker images, local Docker images a repository. So it is going to create a container. So this is the Docker architecture. Here you will have the containers running. Okay, now let us see how it is going to happen. Let me go back here. I think it is the session is terminal. Hold on. Okay, now what I will do here is I want to create a container, Docker run -itd -- name of the container is Ubuntu 01 with the Ubuntu image. Right now, do we have any images in our Docker registry? So local registry, we don't have any images. Docker images, if you can see, there are no images. So no repository, no images are available. So now what I can do, I can execute this command. When I execute the command, there is no Ubuntu image. As there is no Ubuntu image, now what is going to happen here? See that unable to find the image locally. So latest pulling from the library Ubuntu. From where it is pulling? It is pulling from the hub.docker.com. If you go here, here you will have the, let me show you Ubuntu. Ubuntu. So this is the repository which I am searching for. So this is the Docker Hub registry. Inside that we are searching for a repository called as Ubuntu. Inside this Ubuntu repository, we are having multiple versions. So if we don't provide any tag, here I did not provide the tag like colon version 1, version 2204, 2004, 1804, like that I did not provide any version. If I don't provide any sort of version, then it is going to pull out the latest tag. So whatever the Ubuntu with the latest tag is there, that it is going to pull out. So see here, it is going to pull the Ubuntu latest. If I provide the version number, let me show you this. Docker run -itd -name Ubuntu 02 and Ubuntu version number is 2004. So now it will go and search in the particular Ubuntu machine and it is going to pull out that. Now if you can see Docker images, you are having two repos. One is Ubuntu latest and the other one is Ubuntu 2004. This is Ubuntu latest, which is having, so Ubuntu with the tag latest, which is of size 77.9 MB. And the next one is Ubuntu 2004, which is of size 72.8 MB. So which means that if you provide a precise tag, it will go and search with that particular tag in the Docker registry. So if it is available, then that is going to pull out. If it is not available, it is going to throw an error. So now what happened here? If it is unavailable, if it is unavailable, the Docker image is unavailable, then the Docker daemon will go and check out for the same image in the Docker Hub registry. It's a public registry, guys. You can make two types of registries in the Docker Hub. Either you can create your private registry or public registry. Right now, the Docker Hub, whatever we are using from where it is pulling is completely a public registry. Okay. So all the images are free for every user. You can also pull out that. So from there, it is pulling the images and from that images, it is creating the container. So this is what happening. Now, so these images are environments. So these images will create an environment in the containers. Why we are using the images? See, if at all, if I purchase a computer without installing the operating system, am I able to run any application? This is not possible, right? Without installing the operating system, it is not possible. In the same manner, images are the read-only containers. So what exactly is an image? Look at here. What exactly is a Docker image? See here, a Docker image is a file used to execute the code in the Docker container. Simply they are saying use it to execute the applications inside the Docker container. Docker images acts as a set of instructions to build a container like a template. So if you want to build a container, we need to run certain applications. Those applications will be executed in the Docker images. So it's like an operating system which is installed on our laptop, but it is not similar. But just for your understanding, I am saying, if you can see what is the Docker image versus Docker file. So we are going to learn about Docker file slowly. So first of all, let us see what is the main difference between container, Docker file and Docker image so that you can get a very much clarity on this. So now this is the best example. So now what I can do, Docker file is a template. We are going to write a Docker file to build an image and this image will create a container. Try to understand. If Docker file is helpful for you to build the image and the image is helpful for you to run the container. Now what exactly is a Docker image? See here. Uh, hmm. Images are read-only blueprints that include the container creation instructions. A Docker image is a container created to operate the Docker framework. Considering an image, a blueprint or a picture of what will be in container when it is operational. So so what is an image? It's a simply read-only container. Whatever you are seeing here, it's a read-only image as a read-only container only. So now inside that image, whatever the instructions that are there, all those instructions will be running and that will be create a container. So now what is the exact meaning of that? For example, now I want to create, so if you see here, we are going to take the base image. Now what is the base image that I have taken here is Ubuntu as the base image. Now see here, Docker PS. When I give this command, Docker PS. So now when I am running this command inside this container, do we have any softwares? We don't have any softwares. We don't have any applications that are running. It's just a base image. With the help of this Ubuntu image, we are creating a container. So an image will be helpful for us to run the application. But right now inside this Ubuntu image, we don't have any sort of application dependencies also. So now what I will do, I will go inside the container. Let me show you. Docker execute -it Ubuntu 01 bash. When I give this, I will be inside the container. Now, what is my requirement? Apt install, or else I am updating the container. I am installing whatever I require. Apt update -y and apt install -y net -tools and IP utils -ping. And then what is my requirement? That's all. Wget, unzip. These are all the utilities which I want to install inside this container. Look at there. I have installed all the applications related to my whatever the container requirement. So I will go with the ping google.com. As I have installed ping, I can communicate ping google.com. I am able to get it. And the next one is if config. So I'm able to see the IP address of the container as nettools is installed. So the applications are all getting installed. For example, I want Java. So Java is not there in this particular container. Java command not found, right? So I want to install it. How I can install? Apt install -y Java, open JDK -17. I am installing Java 17, guys. If you want, you can go with 8 also. Java 8 JDK. Okay. Now look at here. I am able to install the Java version. Now inside this particular container, I have all the applications that are required to run a particular package. Okay. So see here. Now, what you need to understand here, previously what we have only the base image. With the help of base image, we have created a container called as Ubuntu 01. Inside that container, do we have any application? We don't have any application. Now, what I am doing, I am installing all the application required for me. Now, what I will do here is, here you can see Java-version. When I give this command, Java-version, see that Java is installed. This is good. So if you want to install any application that is related to Java, so dependency, if there is any application that that have a dependency of Java, you can run that application in this container also. Now what I will do, I will go out of the container. I am coming out of the container. Now what I can do here is I can convert this container as an image. So now what is an image? Image will have all the required applications that are used to run the container. So right now, whatever the images that I am having, those are the base images. So if you see here, whatever the images that I am having, these are the base images. Only you are having just an environment. Ubuntu environment is there, but it doesn't have any sort of application. But in this container, we are having, so Ubuntu 01 container, we are having all the required utilities and as well as the Java is also installed. So now I want to convert this container into an image. How I can convert? Docker commit Ubuntu 01 and Java image version 1. I can give like this version 1 or else version 1.1. I can give like that. So if you can see here, we are able to convert this particular container into an image format. Let me show you that. Hold on. Are you able to understand what I'm saying here? Any questions? Docker images. If you can see here, we have a Java image version 1. If I create a container with the help of this image, in that container, we will have all the required software installed. So let me create that Docker run -itd -name Java container with the image that is Java image version 1. Okay. So if I create a container with the help of this, now if you can see here, Docker PS, we have a container that is created that is Java 1, Java container. So now Docker execute -it Java container bash. When I give this command, so I will be inside the container. Now, if you can see, if config is there and ping google.com, we have the ping option is also available, and as well as if you can see here, Java -version. We have the Java version is also installed inside the container. So what we have done, so first of all, I took the base image. So what I have done here is, here you need to understand very clearly. So let me do one thing, Docker PS. So here I took the base image that is Ubuntu. On the base image, I have created a container. So in this container, we don't have any sort of applications installed. After that, what I did here is I have installed and what I have done, I have installed whatever the required applications that I want, applications and dependencies inside this container, and converted this container into an image that is Java image version 1. And with the help of this Java image version 1, what I have done, I have created a Java container. So inside that container, I have all the applications which are required for me, applications and as well as the dependencies which are required for me. So this is how you can create an image, but this is from the Docker container, but this is not feasible. Whatever I have said you, this is not at all feasible whenever you are running with the Jenkins. For example, you have to write a Jenkins pipeline. Okay, whenever you want to write a Jenkins pipeline, first of all, what you have to do, you have to pull. So the developers has pushed the code into the Git or else any repositories, Git or Bitbucket repositories, or else GitLab repositories, Subversion. There are so many version control repositories are there. So when the developers has pulled the code into this particular repository, now what happens, that code will be built. If at all, if it is a Java code, it will be built with the help of Maven, and it will generate an .jar file. Okay, I'm talking completely about Java. It is going to generate a .jar file, and this jar file uh, should be created as an image. This jar file or else whatever the jar file that you are running. So to run that particular application on the Docker container, what should be done? It should be included into the image. How it will be included into the image, the jar file? For including, I cannot create a container and convert the container manually into the image. So this is not feasible solution for me. So I cannot create the container, and after that I cannot convert that container into an image in the pipeline. So what I have to do, I have to go with the approach called as a declarative approach. What is the declarative approach? In the sense, we can create the image with the help of a file, called as a Docker file. What is this Docker file? A Docker file is a text file in which we will have the instructions to create the image. Docker file, we are going to create a Docker file, and if I provide the Docker file, automatically the image will be built. If I run a command, the image will be built. So there is no necessity of creating the container and creating and installing all the applications inside the container and then converting the container into an image. It is not required. If we have this Docker file, from the Docker file itself, we can create the image. Okay, so think in a real-time possibility. Is it possible whenever we are running the Jenkins pipeline? So we have to create a base container and we have to go inside the base container. We need to install all the applications inside the container. Manually, we have to do all the things. In a Jenkins pipeline, is it possible for us? It is not possible. So what we are doing, we are going in an approach called as a declarative approach. That is, we are going to create a Docker file and then we are going to run that Docker file, or else we are converting that Docker file into an image. So what is a Docker file? The Docker file is a text file in which you will have all the instructions to create the Docker image. Now, what is a Docker image? Docker image will have all the required dependencies and applications to create a container. So this is the main concept of your Docker image. Understood about this? Any questions do you have? Questions, guys? Don't take much time.
Yes, so what are the Docker image we have created, Java image that resides locally, right?
Yeah, that is locally only. That resides locally. If we want to move it, we can move it to Docker Hub also. I will show you how to move it. Okay. Any another questions? So now what's your question? That is only your question, whether it is resides in the locally or else it is resides in the GitHub. Sorry, Docker Hub. That's your question, or what's your question?
Yes, yes, and how we can push it to Docker Hub is from here.
That I will show you. Any another questions?
Have a base image becomes a container, and from the container we can convert it back to an image. That is the general procedure for application, right? Is that right?
No, this is not a feasible procedure. Actually, in general also, we are not going to do this. We will be going with the Docker file only. Okay, using the Docker file, we are going to generate an image. So we don't require this base image, or sorry, base image is required. Base container is not required. We need to create a container and we don't need to install all the applications inside the container. If we have a Docker file, we can create a custom image. Whatever our required custom image is that we can create that. Okay.
Okay.
Yeah.
So we are skipping the step of
Hmm.
creating the installations of applications individually by going through the declarative or file approach.
Yes, by going into the declarative or file approach, we are going to skip in the sense inside that also it is going to do the same. I will show you. Any another questions? Okay, so now let us go back and create the Docker file. Now, to make you very clear about this Docker installation, let me do one thing. I will go with the Docker stats itself. It is the session timeout is happened. Hold on. Let me go with the next one, declarative format. But before I go into the declarative format, I will do one thing. I will install a Red Hat Linux server. Okay, so it will be more convenient for you. Launch the instance. If right now we are running the Ubuntu server, I will go with the Red Hat approach. Docker underscore Red Hat server. Red Hat, or else I will go with Amazon. What is that? Amazon server, I will go. Amazon. Okay, everything will be similar in the Red Hat and Amazon itself. Yeah, I will go with. If I go with the Red Hat, I need to go with the subscriptions. That's the thing which I'm thinking. But let me go with the Amazon. T2 Micro, AWS default. Then I will install the. Let me install the launch the instance. So once I have launched this instance, what I can do here is let me log in into that server. New session. EC2 -user @ let me provide the IP address. Hold on.
Right now, have you shifted from a Docker hub-based image or container creation to Amazon? Is that what we are seeing?
No, no, no. This is the virtual machine. This is not a container.
Okay.
Okay, I am not. So this is totally different. So Amazon will use the virtual machines. Okay, those are the AMIs. Whatever you are seeing there, those are the AMIs. So if you have a basic Amazon knowledge, so it's not very mandatory. But if you have a little bit of knowledge on Amazon, you will understand this AMIs, Amazon Mission Images. These are all very similar to your Docker images only, but a little bit difficult. This is hardware based. So on the hardware, we are going to create a virtual machine. On the top of that, we are going to install this AMIs. So it's like a virtual machine. So inside the virtual machine, we are running the Docker. Okay.
Okay.
So let me update this. Yum install Docker. Okay, here we have installed the Docker. Hold on. Good. So now Docker PS. Cannot connect to Docker daemon. Okay. Systemctl start docker.service docker.socket. Okay, now let us see whether the Docker is running Docker PS. Yes. Now the Docker is running. Docker PS. Come on. Docker PS. We can say the Docker is running on our Red Hat Linux. Now I will go with the Docker stats. Let me give like this. Okay, good. So now we will go back and check out the image creation, how we can create an image with the help of Docker file. Guys, a gentle reminder for you. This is the last demo. So yesterday we have one demo, and now we are having another demo. This will be your last demo session. And from next Saturday, you have a paid link. Now else you have to enroll for the course, and those who has enrolled for the course, they will get a link, and through that link only you can join. It's just a caution for you. So please enroll if at all, if you understand and if you find my training is working, join into the session. Docker weekend. Now what we have to do here is we need to create a Docker file. The default name for the Docker file is the same, Docker file itself. So see here, Docker file. Okay. Now there are certain instructions. We need to understand each instruction. Okay. So I will go with from. From means it will take the base image. So from which image you want to create the entire image. So here what you have to understand here is whenever we are going with the images, whenever we are creating the images, there will be layers. So what is this layers and other thing we will understand from Ubuntu 2204. It is the image. This is the base image which I am taking. This is the base image which I am taking. And label. Labels are nothing but it's like the tags. So who has created this image? So for example, owner. So the owner of this image is Chaitanya. And you can provide another label like email. You can provide that label also. Okay. So the next one is env, environmental variables. So inside the container, some applications will be running. So those applications will have certain dependencies to run. Okay, we have to pass those variables. Okay, continuously, if we have to pass those variables, we have to make them as an environmental variable. For example, inside the container, I have created a Postgres database. So if I want to log in into that Postgres database, I need to provide the password. So from where I have to provide, I will give in the environmental variables. Whenever I try to log in into that container, automatically the database will fetch out the password from the environmental variables. Whenever the database is started, if there are any dependencies, all the dependencies will be given in the environmental variables. Now what I can do here is, for example, let me give like this password. Password is one of the environmental variable and the value is somewhere like India @1234. This is the ENV. Environmental variables are the variables which are helpful for the application at the starting of the process. Okay, so we can use the environmental variables, or else I can give a clear-cut application for this environmental variables also. In the upcoming time, I will show you how we can use the environmental variables. Either you can define the env environmental variables in the Docker file, or else you can give externally on the CLI. Whenever we are creating the container, at the time of creating the container itself, you can pass the environmental variables. Right now, this is how I am going to provide. Okay, so let me do one thing. And the next one is arguments. Okay, so environmental variables are passed at the time of creating the container. Try to remember this. Environmental variables are passed at the time of creating the container. Arguments are passed at the time of building the image. For example, I want a version. So what I will do here, I will give like version. Version equal to, I will provide a Tomcat version. So what is a Tomcat? I want to run a Tomcat image. So now, download Tomcat. For example, I will go with this. Okay, here we are having so many versions. The latest version is 9.0.85. So I will go with the 9.0.83. Okay, so here I will give the default version number is 9.0.83. And later, if I want to change, I can change that by passing the external arguments. Okay, so arguments are the build commands which are used at the time of building your images. Okay, these are also called as build arguments. Whatever you are seeing here, these are also called as build time arguments. Okay, environmental variables are passed at the time of creating the container. Arguments are passed at the time of running your or else building the image. Now the next one here is what I can do. I can go with the run command. So run command or else run instruction in the Docker file will execute the commands. So whatever the commands that I have provided, apt update -y. Okay, and then run apt install -y, unzip. Then what I can do, net-tools. Net-tools, and then we can go with somewhere like wget and curl. So these are all the utilities which I want to install. Now the next one is run. What I can do here, I want to install Java also. apt install -y Java open JDK -17 -JDK. Okay, and then I want to run wget. I want to download this Tomcat version. I want to download the Tomcat version. This is 9.0.83. So if I go to the bin, so here I have this Apache Tomcat tor.gz. So let me copy the link address. I'll paste it over here. Okay. So now what I can do here is in the place of 9.0.83, I can give this version variable. I can give this version variable. So $version. Okay, $version. And here also I can pass the version. $version. So if I provide this, now whatever the version number that I specify, that version will be downloaded, and then run tar hyphen xvzf, which means the unzipping tar hyphen xvzf, and then I can give like Apache Tomcat this particular tar.gz. Okay, so that particular Apache Tomcat version will be unzipped. And the next one here, what I can do apart from this, that's all. So this is what I want to do. Okay, so with the help of this, I want to run the container, or else I want to create an image. First of all, I need to create an image, and then I want to go for a container creation. Now what happens here? Let me copy the entire file, Docker file, entire Docker file. I will go to, first of all, I will go to the Ubuntu server. Okay, this is my Ubuntu server. Now what I will do, nano Docker file. Here I am going to create the same. Okay, Docker file. Let me save this. Okay, here you can see we have a Docker file created. We have a Docker file created. If you want, you can create a directory mkdir Docker. So this is the directory which I am creating. I am moving the Docker file to this Docker directory. So let me go to the Docker directory. Inside this, we are having the Docker file. Okay. So now I want to build the Docker image. How I can build the Docker image? So Docker build -t. So which means that I want to build the image -t, in the sense I want to provide the name for that image, tagging. This is what I call it as tagging. So I will make it as Tomcat version 1. So I want to create the image with the name Tomcat version 1. And where is the Docker file? From where you have to create the image? From the Docker file, we have to create the image. Inside this Docker file, I have the instructions to create this image, right? So from this Docker file, I want to create an image called as Tomcat version 1. So where is the Docker file? In the current directory only. Where it is? It is in the same directory itself. So if at all, if the Docker file is in the same directory, you have to provide dot. Dot means in Linux or Windows, everywhere, whenever I specify dot in the sense current directory. So the Docker file is available in the current directory. So the Docker will understand this name. So the Docker will understand the file name. So if at all, if it sees Docker file in the current directory, it will create. If the file name is something different, then you need to specify the file name also. I will tell you that, but as of now, the default name which Docker will understand is Docker file. So what is the command that I have given? Docker build. We need to create an image with the name Tomcat version 1, and the image instructions are available in the Docker file. So when I press enter here, look at there. It is running the commands. In Ubuntu, it is showing you like this, right? When I go to the Red Hat Linux or Amazon Linux, it is something different. I will show you there. I will show you the exact configuration. Okay, so it will be creating this. I will go to the Amazon Linux. So here also nano Docker file. I am going to create a Docker file, and let me copy this and paste it over here. Let me save this. Again, I'm going to do the same. Docker build -t. The name
T
is
stands for
tagging. -t is for tagging.
tagging.
AMZ Tomcat version 1. And where is the Docker file? Docker file is residing in the current directory. So when I give this here, it will be something different. I think it is, I have to show you in the Red Hat. It will be perfectly shown over there. Here also it is showing you the same. Okay, that's
But
okay.
shouldn't it be the same or everywhere, because it is eventually
No, it will be different in the Red Hat. What I will do here is, let me install the Red Hat then. See, if I have to go with the image creation, that will be, so I want to show you the layers, how the images will be created. I just want to show you in the form of layers. Let me do one thing here. The image is created. So if you can see Docker images, the image is created. What is that? Tomcat version 1 image is created, and inside this image we will have the Tomcat. It is not running. So up to now what I have said, So here I have given that we need to install all this, and now it is installing. That's fine. Now let me do one thing. I will create an Red Hat Linux and I will subscribe for that. Okay. Mm, Docker underscore Red Hat underscore server. Red Hat server. T2 micro key pair will be English default and select an existing security group. Launch the instance. So now we have the instance that is created. Let me go with this instance. Let me copy the public IP. So here, watch -n-1 Docker images. It will be continuously showing us the Docker images. Good. And now here also on the Amazon Linux also we have this watch -n-1 Docker images. Continuously it will go with the Docker image. So here you can see a Docker image is created. Now I will go back with the Red Hat. Okay, so hold on. Let me copy this. New session. Go with the. So for Red Hat also it will be EC2 -user @ toward this. Okay. Now we have a Red Hat server. So what I want to do here is I need to subscribe this. That is the main problem. Sudo su -, which means that I am going as a root user. Subscription manager register. If I go with this, the username is I have a Red Hat account. Good. Now once it is registered, okay. Now what I have to do, I need to check whether it is registered or not. For that, subscription manager attach or else attach -auto. Okay, good. Good. So now my Red Hat is subscribed. Now what I can do, DNF update -y. Okay, hold on. Good. And then I will install the Docker. DNF install Docker -y. Hold on. Okay, good. Just hold on, guys. 2 minutes. Okay, good. So now we have successfully installed the Docker. So Docker PS, it won't show you. Okay. Yeah, Docker PS. Okay, good. So now what I will do here is I will create a nano Docker file. I'm going to create a Docker file. Okay. Yum install -y nano. You can give DNF or yum, no problem. Okay. So nano Docker file. Here I will copy this entire file and paste it over here. So let me save this and then Docker build -t Tomcat version 1 and dot. Yeah, this is what I want. Previously you have gone something like different, right? So this is what I want. I will explain you this. Okay. Hold on. So total, how many instructions we have provided? Total 9 instructions are there from label, environment, arguments, and then run commands. So if you see here, the run commands, there are certainly some 5 run commands are available, right? So hold on. So it is now installing the Java. And then it will be downloading the Apache Tomcat. Hold on.
You're saying that the process to
Mhm.
different flavors of operating systems or Linux
Mhm.
variants have different methodologies to execute the same 6 or 7 instructions for the Docker.
Not different, but see here in this particular page, I cannot show you what are the layers. If you see here, I cannot properly explain you how the layers are created. See, so from the as it is same on all the flavors, the Docker will execute the same. But here, Red Hat or else Ubuntu is not showing you the proper layer creation. So what are the layers? How the images are created? Step-by-step process it is not showing. It is directly going ahead into the I am running this command. So what happens if the Docker runs this command? I am running this command. I am running this command. So it is just showing you how it is running the command, but it is not showing what happens in the backend. So in the Amazon Linux also the same thing was repeated. If you see here in the Amazon Linux also, it is just showing that I am running this command. So apt install, where is if there is a problem, where is the problem? So here on the Red Hat Linux, it is showing you the entire process. Here you can see. So here we have created Tomcat version 1 in the local host. Now what happened here? Here you can see every instruction is there. It is downloading this, whatever, what else it is downloading, everything it is showing, right? So let me go ahead with the Docker image creation so that we will get a clear picture. So now, what I will do, I will try to recreate the image so that you will get a clarity. Okay, so the first thing what it is doing here, before I go into this concept, let me remove these two, installing and all the things, so that we will understand a single process. I will remove this Java also, or else in place of Java I will give Nginx. Okay, I want to run with the Nginx. Okay, so now what I will do here is nano Docker file. In the Docker file, I will remove everything. Why? Because I am unable to show you the exact thing. Okay. So now I have created this. Or else Docker images. Here we have localhost Tomcat. This is the one, right? So Docker RMI. So what is the image ID? This is the image ID. Let me remove the image ID. Okay. And as well as Docker RMI, I will remove the another image also. Let me remove that. Okay, good. So now what I will do, Docker build -t The image name is Nginx version 1. Right now I am creating the Nginx version 1 from the Docker file. Okay. Yeah, this is what my requirement. I will tell you what happens here. Now, if you can see here, let it come. So we'll see the Nginx also. It's I don't think it will take so much time. Good. So now Nginx version 1 image is created. Now the point what you have to understand from here is right from here we have started the image creation. Look at that. Docker build -t Nginx version 1. Now what it is doing from Ubuntu 22.04. So from this what we have done, you have to take the base images from Ubuntu 22.04. So it took the base image Ubuntu 22.04, but that is not available in locally. So it is deleted. So it is pulling the image from Docker Hub, Docker IO/library Ubuntu 22.04. It is copying and pulling that. So after pulling that, what it is doing, see, it is creating after the pulling of the base image on the base image, it is creating an another container. Try to understand this. Label owner Chaitanya. Here you can see we have an label. So on the image we have a label. And the next one is environmental password. So we have given the environmental variable as password. For that also it is creating a container and removing the old container. So it is like a temporary container. So how we are running the images, or else how we are how we are creating the container on the base image container, we are installing all the applications and then we are converting that container into an image, right? In the same manner, the Docker file also backend, what happens here is whatever the instructions that we have provided, all the instructions will be created in the form of a container. A temporary container will be created and that container will be converted as an image, and that image will be as a layer to the primary image. So now what happened here, again telling you, first what happened here, we so whenever we are executing the Docker file will create a base container, okay, base image layer. Okay, on the top of this, what is the instruction that we have provided? We have provided label owner Chaitanya. So this particular instruction will be executed in a temporary container. So the Docker will create a temporary container. Inside that temporary container, it is going to create, or else it is going to execute this particular command, or else this particular instruction, whatever we have given, and this container will be converted as an image, and this container will be converted as an image, and that will be in the layer format. Now that layer will be appended on the base layer. Okay, that layer will be appended on the base layer. Now what happened here, on this layer, we will have this label owner. And next one is, what is the instruction that we have provided? Environmental variable. So now this is also, first of all, it will create a temporary container and then it will be converted into an image layer. Layers of image. Okay, and then what happened here, the next instruction will be created as an another layer. On the top of that, again, an whatever the apt update, that is an another layer. Here you can see where is this apt update -y, it is also created as an layer. Let me go down here. Here you can see a layer is there, and later on if you go down here, apt install nginx -y, look at that. So see, commit nginx version 1. So it is committing, the final image layer will be this one. So what happens, whatever the instructions that we have passed, all the instruction will be, first of all, they will be executed in a temporary container, and that container will be converted as an image layer. And on the top of those, all the layers, whatever the instructions that we have provided, these are all the layers. And finally, we are going to get an output of Docker image. So by combining all these image layers, we are going to get the Docker image. So this is what happens that I want to show you. So that's the reason I have created this Red Hat Linux. In Red Hat Linux, we can clearly see how the image layers are getting created. So previously, in the previous image also, we have the first one, we will have the base image will be pulled from the Docker Hub. On the top of that, whatever the instructions that are there, those will be converted as a container. On the container, those will be executed, and whatever the containers that have been executed, they will be converted as a layers, and the temporary containers will be deleted. So this is the process. Layer by layer, we are going to create the image. So that is how your Docker image will be created with the help of Docker file. So Docker files are the declarative form of your Docker images. Do you understand this? Any doubts? Any confusions here? Guys, questions?
No, in both cases, maybe similar things are happening. In Red Hat, it is more transparent where we can see the layers happening.
Exactly.
So, okay.
Mhm, mhm.
So we are attesting, we are acknowledging that in both cases, similar thing is happening.
Both cases in the sense you are talking
In
about the
Ubuntu versus Ubuntu
yeah,
Amazon.
in
Okay.
the both the operating system, same thing happens, but here we are unable to see what happens. See, here it is
Yeah.
just showing you the images are getting created. That is what it is showing. Okay, the layers are creating. That is what it is showing. If you see here, I am running this. The layers are creating. But how it is creating? It is more precise in the Red Hat. So this is how the image layers will be created. A container, temporary container will be created, and with the help of that, we are going to create a layer. So the layer ID is this. On the top of that layer, we are creating this layer. The layer ID, the second layer ID is this. So by combining all the layers, we are creating a image. So here it is not showing that. For that more clarity, I have installed the Red Hat Linux and I showed you. Okay.
Yes. Right.
So that's about your Docker images, guys. How we can create the Docker. No, these are the basic. No, I did not went for all the instructions. We have so many instructions that we have to go through. I will tell you the instructions one after the other. So right now, take a small break. Right now, the time is 10:42. Take up to 10:55. We will join at 10:55. Okay. You can get the recordings, Chandrasekhar. Take a break up to 10:55, guys, and we will come back. Uh, that we will see. Rakesh, we will see about that. Okay, so that's it from my end. It's not from my end. We will continue the session. At least I have to complete the Docker images. I don't know whether the Docker volumes will be completed in this session, but let us see what happens here. So give me a 15 minutes of time. I will be coming back to you. You also go and have some breakfast and come back. Okay.
Yeah. Thank you.
এরকম
Welcome back, and let's start. So up to previous concepts, like whatever we have discussed, that is about the images. So in the images we discussed about the run prompt, right? Run, label, environmental arguments, and all the things. And here we have a doubt or also a question. If we are trying to log into MongoDB, environmental MongoDB equal to India at the rate 123. That's correct. So automatically we can log in into this. So you can pass that environmental variable like that. Okay. So whoever has asked, like I think it's Praveen who asked me. So that's correct. Now when we coming back to the next one. Now here we are having the images, label owner, environmental pass variables, and then arguments and run command. So here you can see how many ways we are running the. So if you can see here how many run commands that it is passed. Here you can see we have certain somewhere around 6 out of 7. Okay, 6 out of 7 in the sense we are passing overall 7 run commands. So 7 steps that we are passing. So now I want to use this run command in a single step. If you can see here also, we have like 5 out of 6 steps. So every run command is running like a separate step. Okay. So I want to run it in a single command. So how I can run as a single instruction? Now in the place of run, I will remove this run and I will provide double and. Okay, here also let me remove these run commands. Okay, and then you can provide double and. Okay, and at the end of this, you can provide small slash or else like forward slash like this. Now, when you provide this automatically, it will be converted as a single image. Okay, so or a single instruction. So we don't need to go with the multiple instructions. Okay. So now if I try to create the Docker image with the version 0.9.0.85, I will try to run the Docker image with the 9.0.85. So what is the main functionality of the argument? You have to know about all about the argument also, right? So now what I will do here is I will go back to my Ubuntu machine. We take a duplicate session. The session might be terminated. Hold on. Here, nano, or else let me check. We have the Docker directory. We don't have the Docker directory. Sorry, SU Chaitanya. Okay. Yeah. Here I have the Docker directory. CD Docker. Now, if you see here, we are having the Docker file. If I create the Docker file with a different name, so we have to create the Docker file with the Docker file itself. The name should be Docker file itself. For example, now if I create that with a different name, so nano, what I can do, Docker file or also Tomcat Docker or else Tomcat file. I will give like this Tomcat file. If I give this, so we are going to provide the entire instructions over here. Now what I can do here, the default version is 9.0.83. This is the default argument. So what happens? The version will be replaced with 9.0.83 so that 9.8.03 version will be downloaded. But now what is my requirement here is, see here, Docker build hyphen what I can do here is arguments or else build arguments, build hyphen arg. So I have a small doubt here. Docker build hyphen help. I think that's the correct. Docker build arguments. We have to pass the argument. Oh, come on. Hyphen arguments. Build arg. That's correct. So where is this? Docker build hyphen build hyphen arg build arguments. So the argument is version is equal to 9.0.85. So previously we have given the version number as 9.0.83. Now I am replacing that with 9.0.85. And then we are passing now. That is the reason why I said arguments are passed at the time of creating the images. -t. The image name will be Tomcat. So I will simply give the version number 9.0.85. This is the version number. And -f. Previously, we have given the dot command. Dot in the sense it is not, we don't need to provide the file name. But here we need to provide the file name. Why? Because the instructions are in a different Docker file. -f file name. The file name is Tomcat file. Where is the file residing? File is in the current directory. When I have to represent the current directory, I need to provide dot. Okay. So if you see here, look at that. It is creating the same, whatever we required. So how many steps it took? It took only 2 steps. Why? Because this entire thing, it has taken in a single format. Like up to here, it's taken as a single line, and the remaining, all these commands will be executed in a single line. So now look at here. Hold on. It will take its own time. Now, that is one form of creating the Docker image, or else running the Docker image instructions in a single line. Okay, whatever the instructions, or else whatever the commands that we have to execute, all these commands will be executed. And whenever we are creating the container, inside the container, every instruction will be there. So now you need to understand one more thing here is, whenever we create the container, inside the container where we are landing, if at all, if you are logging into the container, we are into the slash directory in the sense root directory. So hold on. So see there, exporting the image, exporting layers, and creating the container. Now, if you can see Docker images, here we have Tomcat 9.0.85 version. Now what I will do here, Docker run -itd -name Tomcat container with the help of which, sorry, the image name is mistyped. That's okay. So Tomcat version 9.0.85. With the help of this image, I want to create the container. Now, if you can see Docker PS, we have a container running. What is that? Tomcat container. Let me log in into that container. Docker execute -it, or else TI also you can provide. Come on. Okay, the container name is Tomcat container, right? Tomcat container. Okay, so now I'm sorry, I have to give bash, right? Bash. So now I am inside the container, but where, in which locality we are in the current slash means root directory. If you can see right now, the user is in the root directory. Here only you will have this Apache Tomcat executed. So everything is like this. Now the point is, right now I don't want to execute the, or else right now I don't want this Apache Tomcat to be in the root directory. So my working directory, I want to create a working directory. In that directory only I have to run my applications. In that case, what I can do here is, I can give an instruction. The instruction is working directory is /app. A new directory should be created with the name app, or else I can give like this, Tomcat app. This is the name of the directory in which I have to run my, or else in which I have to execute, or else store all my data. So now if I provide, so working directory is the directory which is created, or also where we can copy all our, where we can copy or store all the data. Okay, so now what I will do, I will try to execute this particular command. And before I go into this next creation of the next image, so if you want to copy any file from the local machine to the container, if you want to copy any file, for example, copy. So copy is the command which I have to use. Let me go with my, so here I will go to where we are in the Amazon. This is not what I want. I don't want this. Yeah, this is my Ubuntu container, right? So I will come out of the container. To come out of the container, you can give exit command, or else in the keyboard press Control PQ. If you give Control PQ also, you will come out of the container. So right now I am out of the container. I will create a file, nano test.sh. This is the file which I am creating, test.sh, which means I am writing some shell script, shebang /bin/bash. Okay. So now what I want to do here is echo welcome to the Tomcat container. Okay, this should be executed, and the next one here is echo $date, or else let me write a for loop for I in 1.10. I want to create some 10 files. Do echo $date append file, or else access, the file name should be access $I, which means that access1, access2, and access3, and sleep, or else ls-al, and sleep1, and done. This is the file which I want to create, which should be executed. Let me save it. So if you can see here, we are having a file. What is the file? Test.sh is the file. And then we are having a Tomcat file also, or else this is the image file. Okay. So now what is my requirement here is I want to copy this test.sh file. I want to copy this test.sh file into my container. So now what I will do, copy test.sh file, okay, which is located in the server to the so we will be working in the Tomcat app directory only. In the name should be file gen.sh. So this file should be copied, the test.sh should be copied into the container with the file name file gen.sh, and then it should be executed. Let me show you. And / first of all, let me provide the permissions. chmod 777 file gen.sh. I will provide this, which means I am giving the permission for file gen.sh, and then what I will do here is I will execute that file / file gen.sh. So when I execute this, all the files should be created. So this is the command which I want to run. Okay. So now this is the copy command. So which will do the internal, whatever the files that are available internally in my server. If I want to copy that files into my working directory, or else into my containers working directory, then I can use a command called as copy. So the next one is add command is there. First of all, let me complete this copy command, and then I will come back to the add command. Nano Tomcat file. Here I will give like this. Let me save this. And then the same, I'm going to build the Docker file. Okay. Tomcat, the file name is, or else the image name is Tomcat version 8.0.86, or else any version. Let us suppose think version 1.2. This is what I am giving. Okay. If you can see here, good. See here, copy test.sh file. It is copying the test.sh.file to filegen.sh. And here you can see working directory, Tomcat app working directory will be created inside that container. Let me show you that after creating this image. Hold on. Java is installed now. And then we need to get the Apache Tomcat. Okay, hold on. Good, good. Now you have to look at this. So now we are downloading the Apache Tomcat. And then here you can see file gen. See there, access 1, access 2, access 3. So files are creating. Why? Because it is executing the file gen. So access 9 and access 10 will be created. So all these files will be created in the working directory. Let me show you there. Okay, good. So now if you can see here, Docker images. So we have the Tomcat version 2. Let me create a container. Docker run -itd -name test Tomcat. This is the container name with the content or else with the image name as Tomcat version 1.2. With the help of this, I want to create the container. So if you can see here, Docker PS, we have a container running, that is test Tomcat container. Let me log in into that. Docker execute -it test Tomcat container and bash. When I give this, automatically I will be inside the container. So now look at here. Previously, whenever we have logged into the container, we are in the slash directory. Why? Because there I did not provided any working directory. But now as I have provided the current working directory, now what I am doing, so when I create the container and when I try to log in into the container, directly I will be into my working directory. So if you give /app, you will be into the app directory. If you give like /home/app, or else /home/python /home/java, you will be into that container, or else you will be inside that directory. Okay, now if you see here, see that access 1 to access 10, the files are created. Why? Because in this file gen.sh, now what I have said in the copy command, I have clearly mentioned that the test.sh should be copied into the file gen.sh. Now it has been copied as a file gen.sh. And then what I have said, Tomcat version 1, in the build arguments, I have provided the version as 9.0.85. So 9.8.05 version has been downloaded. See here, that has been downloaded and that is unzipped. So with the command called as tar-xvzf, with this command, the file has been unzipped. And the next one, what we have did here is we have provided the file permission. See here, ls-al for the file gen.sh, we have provided read write 777 in the sense for all the users, we have given all the permissions. And the next one is we want to execute this file gen.sh. When I want to execute file gen.sh, in file gen.sh, what is there? So access, we need to create some files, some 10 files. So it is creating the 10 files. So satisfied with all the conditions, whatever we have provided in the image. So this is how we can go with the copy and working directory command. And the next one here is we have an instruction called as add. So what is this add instruction? Add instruction will download any data from the what I can say from the URL, from the given URL. For example, I want to download Terraform. So Terraform is also a DevOps tool, guys, which will be automating or else automatically creating the resources for the users in the cloud. Okay, not only in the cloud, in the virtual machine also. So let me copy this link. I will go back to my add. So I want to download this Terraform, and that Terraform will be like I will give like this. So add command will download the Terraform and copy the Terraform into the current directory. So now what it is doing, it is copying that. And the next one here is after downloading the Terraform, I want to unzip it. Unzip Terraform. So this should be done. So what is the main difference between copy and add? Copy is a instruction which will be helpful for us to copy the files from the local server to the container. And the next one is add. Add is a command which will download the file from the given URL and copy it to the container. So this is the main difference between copy and add. So now let us see whether what is going to happen. This time I will go with version 8.4. Okay, Tomcat version 8.4. And let me remove these versions, whatever the Tomcat versions that are available, rm-rf. I will give like star. I am going to delete everything in the Apache Tomcat. So everything has been deleted. Okay, no need of this also. Let me copy this. I'll go back here. Let me come out of the container. Okay, nano Terraform. I'm going to create a Docker file with the name of Terraform. Let me save this. And then Docker build -t, Docker build -t, Terraform version 1 and -f with the file name Terraform. Where is the file name? The file is available in the current directory only. Dot. When I give this, it is going to build the directories. Okay, good. So do you understand this? So let it build it. Any questions here? Up to here, is it clear? So do you get it? Do you have any understanding? Do you got any understanding about the Docker file? How to create the images from the Docker file? Any questions here?
Suppose if I want to create a container with like I have multiple Docker files, I want to import all those Docker files into a single container. So
Why you want to create multiple Docker files for a single container? Well, you can't run all the commands in a single file, no?
no, it's like I already have the files. So I need to, instead of copy paste, I can only import the files and
So
I
that is
can
not
run
possible.
the no.
So what's your question? I did not understand. Come again.
See,
So,
I have a Docker file 1, Docker file 2,
Mhm.
and these two files have a multiple instructions in it.
Mhm.
So based on these two files, I want to create a container.
Then you can copy. Then what is the necessity of multiple files? That's my question.
It has a dependent. It has a several package in that project.
No, you can run all the packages in a single file, no?
Single. Okay, from like I can Docker file 3 and I can import these two files in that.
No,
No.
that's not possible. In the first place, my question is why you want to have multiple Docker files. Despite of that, you can have, if you have multiple dependencies also, you can write in a single file, no? Then why you need to go for multiple files? So after creating the container, the dependencies, what is the scenario over there? So
No,
now I have
Mhm.
explained you one of the scenario. So now what I am doing, I am slowly increasing the Docker file content. Okay. So
Okay.
now, if you know the clear-cut dependencies, then what is the necessity of creating two Docker files? Why can't you create in a single Docker file?
Mm-hmm. So you want me to go with a single Docker file only? Yeah.
Single Docker file is enough, no?
Okay.
Yeah. Now here you can see we have
Hello.
completed the, yes.
We have argument variable and add red. Both are doing same only, right?
Which one?
We have argument variable, right? ARG.
ARG variable will be, see what is ARG and add are both are different, guys. Now don't get confused with argument and add. So what add will do? Add will download the file from the given URL. It is going to, now what is the argument? You are making like a very big, so you are thinking like very, very far. But here the point is argument is like a variable. If I give here in the point of version also, if I provide X, I can replace X here. So it is just for storing the values. Arguments are used for storing the values, and at the build time, I can change the values. But what is add? Add will download the file from the URL. So that's totally different thing. So now where you got the confusion, you tell me that so that you can get a clarity.
Yeah, actually here we downloaded, right? So
Where we have downloaded
from
in the
from
argument
the repository.
No. In the argument, if you see argument, did I downloaded anything in the argument?
It is in the public repository, right?
Which is in the public repository?
For example, we download Tomcat from the public repository.
Yeah, we have downloaded Tomcat. For that, we have given a command here, right?
This is
So here the argument, what it is doing, argument is storing a variable and that variable is replaced here, which means that arguments are used for storing the variables, not for downloading and copying the data. Okay.
yeah, okay, got it.
Yeah. So now when we get back to this, here you can see We have the Docker image created. What is the Docker image that is created? Here we have Terraform version 1. What happened to this Terraform version 1? Docker run -itd -name Terraform, and the image is Terraform version 1. A container is created. Let me go inside the container. Docker execute -itd, sorry, Docker execute -it Terraform, and with the bash. Let me give bash. So right now I am inside the Tomcat app. If you see here, we have the downloading. We downloaded the 9.8.0. So previously the version number is 9.8.03. Now it has been converted to 9.0.84. And again, I can pass a argument variable as 9.0.85. So now what happened when I pass the argument variable as 9.0.85, that will be replaced here. 9.0.85 will be replaced here, and it is going to download 9.8.05. Now the point is this argument will help you to store the variables, and this add command will download the value from the given URL. So if you see here, it has downloaded the Terraform 1.7.3 and I have unzipped the Terraform. So this is what happens with the add command. So this is a bit, so this is how we are going to execute the Docker images. Now here my requirement is not satisfied. What is my requirement? My requirement is to continuously run the Apache Tomcat. So my requirement is to continuously run the Apache Tomcat. But now what happened here? My requirement is not satisfied yet. Why? Because the Apache Tomcat is not running continuously. So we have downloaded Apache Tomcat and we are running the Apache Tomcat. But now what is my requirement? I want to run it continuously. I just unzipped it, but if I want to run anything in the backend, so now what I have to do here is I want to go with an instruction called as CMD. CMD is an instruction that will be used to run a command continuously inside the container. So what is the main difference between the run command and CMD is run command will execute the commands whatever we have given at the time of image creation. Now it is, so what run command is doing? Run command is executing the commands at the time of image creation, whatever the commands that we want, net tools and all the things. CMD is an instruction which will be help us to run a command continuously inside the container. At the when the container is started, I want to run an application. For example, if you want to run an Python application, then what you will do? What is the command that you will give to run a Python application? Anyone, any Python developer is there? Any Java developer is there at least? If you want to run a Java application continuously, then what is the command that you will use?
For Python,
So
we
either
need to
Python or
Python
Java.
doing script name.
Python space application.py, app.py. That is what you are providing, right?
Yes.
For Java, it will be java-jar, and then you have to provide the jar file name, if I am not wrong. Yes or no?
Yes, yes.
Yes, that you will execute. So what happens when you execute that command, that will be running in the backend of your server. That application will be continuously running. Now my requirement is to run the Apache Tomcat. So what run command has done? Run command has downloaded and run command has executed all the, or else installed all the requirements. But after installing the dependency, I want to run the Apache Tomcat application. How I can run the Apache Tomcat application? So to run the Apache Tomcat application, now what I have to do here is I need to execute a command that should continuously run it in the backend. So to continuously, after starting the container, if an application has to run continuously, so in the CMD instruction, whatever the executable command that we will provide, that command will help us to run that continuously. Now see here, CMD, I think that is Catalina. I just, hold on. So here, there is a Catalina.sh. This one. This is for Nginx. I think there is Catalina. So Tomcat to run continuously. CMD to run Tomcat in Docker. Okay. CMD instruction, Docker command, not the Docker command. CMD instruction to run the Tomcat image in Docker. So there is a catalina.sh is available. With that, we can run that particular command. Hold on. Hold on. We don't report all these things. Yeah, catalina.sh. This is what we want. Let me copy this. Let me copy this and I will go back to my Docker file. Where is the Docker file? Okay, this is the Docker file which we are running. Okay, good. So now what I can do here is I can give CMD. The executable is catalina.sh. I can give like this. Where is the catalina.sh? The catalina.sh will be available in the current directory. So where we have unzipped it, unzip the tar. So in the current directory, we have the Apache Tomcat version 9.8.04, right? So now what I will do here is, once you can go ahead with this, but let me go with this Apache Tomcat version. Let me copy this. Version is not, I don't want to provide the dollar version here. I will provide like 9.0.84/bin/catalina.sh and run. So this is the command. So this is the CMD. So this command should run the Tomcat continuously in the container. So if you want to run any application in the background of your container, you have to run that in the CMD. You have to provide that in the form of CMD. Okay, so the next one here is, let me copy this Docker image file and I will go back here. It is good. So nano Docker file. I will go with the Docker file. Every time it is very difficult for me to go ahead with the CD Docker and nano, or else whatever the files that we are having here. So let me check out this. So we are having Terraform, Tomcat. So I want to delete these two files, rm-rf, Terraform and Tomcat. So I'm removing those two files and I will go with the Docker file itself. Nano Docker file I'll replace here. Okay, so this is what I want to do finally. Okay, let me save this and Docker. Let me remove all the images. So what I can do, Docker system, unnecessary they are running. So Docker system -a -f. Okay, I want to delete everything. So see that 9 point, so somewhere around 3 GB of space has been consumed. Docker images. So images -a. Okay, Docker ps. Still we have, let me do one thing. Docker docker rm -f. I'm directly removing all the containers, guys. Don't do this in the in your company. Okay, it's a mistake. Docker ps -aq. Ah, come on. Okay, now docker rmi -f dollar docker images -aq. Good. So everything is deleted now. Good. Everything is removed. So here you can see Docker images. We don't have any image, or else Docker ps-a. We don't have any containers. So everything is clear. Now what I will do here, you can see we have a Docker file. So now Docker build -t. What is a Docker file, or else what is the image file that I want to create here is Tomcat version 1 and from the current Docker file. Okay, it is building the same. Hold on. Very good. And it should execute this command cmd Apache Tomcat 9.0.84 cat lena.sh and run. So if it is done, our Apache Tomcat will be executed.
But you did not write at and in front of this command.
Sorry,
Ampersand you did not write here.
what is the necessity? It is a different instruction, right? So run command will be executed at the time of creating the images. See, this is executed. All the whatever the required commands are running. So here you can see this is running as a single file. But CMD is executed after image is created, and inside the image we will have the CMD. At the time of we are starting the container, then the CMD will be running. So this is different and this is different. Run is different and CMD is different. Run commands, or else run is an instruction which will execute the commands at the time of creating the image. CMD is an instruction which will be running the command at the time of creating the container. When the container is created, and if you want to run an application continuously in the background, then you have to use the CMD. So both are different, guys. Both are not same. So here we did not provide that and double and slash values. So this is for only installing the dependencies. This is for running the application. Now, do you understand? Now let me check. Yes, our container is ready. Sorry, image is ready. Docker. Come on, Docker images. Docker images. So right now we have the Tomcat version 1. So let me go with Docker run -itd -name web app. This is the application or as container name -p. What is this -p? So now how do I know the Tomcat is running in the background? How do I access the Tomcat application or also any website that is created in the Tomcat? Now you need to understand this, very important. Now we have a server. We have a server, and inside the server we just install the Docker. Inside the server we install the Docker, and inside the Docker we are running a container. Okay, inside the container we have the Apache Tomcat application running. Okay, so now when the client is trying to access this, so what is this? This is a server. Again, I have to write all these things. That's okay. This is the server and Docker engine. Docker. Okay, it's a Docker. And the next one here is, this is my container. And this is my application, whatever the application that I just said. Okay, normally the default port number for Apache application is 8080. The port number for Apache application is port number 8080. That is the default port number. On this port only, the Apache Tomcat will be running. Okay, so now what I will do here is watch -n1 Docker images, or else it will be terminated. Let it come. So now on the port 8080, this application will be running. Okay, the container will be running on the port number 8080. So when the user is trying to access that particular content from the app, that particular content from the application, first of all, the request has to reach to the server. First of all, the request has to reach to the server. In server, we will have some logical ports, if you remember. So do you know what is the port number for HTTP protocol? Any website that you want to access, what is the port number that should be opened on the server? Do you have any idea about that? So when I give this, yes. Go ahead. You want to tell? You want to
No,
tell?
no, 80, 443.
Yeah, 80 and 443. If I want to access any HTTPS website, then port number 443 should be open. So on the server, port number 443 should be open. Or else if any website is running on port number 80 on the HTTP, then port 80 should be open. So these are the logical ports which should be open to accept the incoming traffic. If the traffic that has to enter into the server, certain port should be open. So those are like your gateways. So for the server, the ports are like entry and exit points. If any request has to enter into your server, one port number should be opened. So here -p, when I give the option -p, docker run -it -name web app -p, I want to open port number 80, or else you can go with 8080 also. Okay, port number 8080 on the server, that should be forwarded. Any request that is coming to any request from the client that is coming onto the server port number 8080, that should be forwarded to the container on the port number 8080. So now what I will do, I will go ahead with the container port number as 8080. So what it is, this is the server port number. So on the server, whenever I am communicating, whenever I am requesting any data on the port number 8080, that request will be forwarded to the container's port number 8080. So if there is any application that is running on the port 8080 on the container, then the container will provide a response to the server, and server will give the response to the client. If there is no application that is running on the port number 8080 of the container, then the container won't provide any sort of response to the server. So let me give a small example. I will go with 80. So the meaning is, on the server, if the user is hitting on the port number 8080, if the user is trying to access some data from the server on port number 8080, then server will forward the request to port 80 of the container. So do I have any application on port 80? We will see. If there is no application, I'm going to get an error. So this is what port numbers that we are going to assign. And with the help of an image called as Tomcat version 1. With the help of this image, I want to create a container. See here, Docker PS web app. Oh, it is exited. It is exited. Why it is exited? Now let me check out what is the problem with this. To check why the Docker container is exited, we can go with the Docker logs. I can provide the container name. When I provide the container name, unexpected operator, we have an unexpected operator here, guys. What is the unexpected operator? Everything is good, but why it is showing unexpected operator here? Apache, Tomcat, Ben Catalina, comma. It is good. So this is what we have to execute. Comma, run. Everything is fine. Why it is an unexpected operator? Let me remove the space over here. I'll give like this. Here also I'll give like this. Okay, let me save it and I will regenerate the image. Nano Docker file. This spaces is causing some trouble. Okay, here also I will remove this. Let me go ahead and let me recreate the image. Docker build Tomcat version 2. So it's just as everything will be cached. From the cache, it is going to take the image. Now what I will do, Docker run web app 2. Okay, let me run the container again. Docker ps Docker rm web app container. Okay, good. So Docker run -itd -name. Again, I can go with web app. Why? Because I have removed the container. If you don't remove the container, the Docker won't accept. Already there is a container, so you cannot create the container with the same name. But I have removed that, so I'm creating the container with the same name. -p 8080. This is the server port number :80 and Tomcat version 2. Docker ps. Again, Docker ps -a. Why it is Docker logs? Docker logs. So let me check out this container. So this is how you can troubleshoot it. Not found. Catalina.sh is not there. So let me check out this.
Just check the path.
Yeah, that is what. Let me check out this. I think. Let me give the total entire path. /tomcat/Apache. Okay, this is what the path which I can give. And I will check out this Apache Tomcat, right? So I think it is fine.
Bin folder in this root, I mean Apache Tomcat or somewhere else.
No, this is the bin folder. Here you will have the, or else let me do one thing to make sure that I will remove this without this CMD. Let me execute that so that we can understand where is the bin folder. So bin folder is available in the Tomcat. I know that. So, but I just want to make sure this Apache Tomcat version 3. It's finished. Docker run -itd -name web app 2 web 2 and Tomcat with the help of Tomcat version 3. Docker ps. Now we have the web 2 Docker execute -it web 2 web 2. I think I have given the spelling wrong. Web 2 and bash. So now we have this. Let me go to here. We have the Apache Tomcat 9.0.84 cd Apache Tomcat 9.0.84. Here we have the bin folder cd bin. Now we have the catalina.sh. There you go. This is what I want to execute. So everything is correct. Let me save this. Okay. So now what I will do, pwd. So Tomcat, Apache Tomcat, I'm going to give the relative path. Okay. Or else I will give the absolute path or the relative. I will provide the absolute path over here. Let me provide like this. Okay, and save it. So now we will execute this entire Docker file. So let me go back to this exit. Okay, cool. Now here you can see Docker ps. What you are seeing here, you are unable to see the port numbers, right? Ports are not exposed. I will tell you there is another command for this nano Docker file. Let me go with this. And then what I can do here is let me create the image. Docker build. I will go with version 4. Okay, good. So now Docker run I will go with the run command web app 3. Docker name web app 3 and Apache Tomcat version, or else here we have created a image with version 4. Okay. So now we have a Docker container created. Docker PS. We have a container created and that is exited also. Why it is exiting? Docker PS -a. It is also exited. Why? Docker logs. Docker logs. Tomcat not found. Why it is not finding it out? Tomcat Catalina.sh is there. Let me check out this. Apache Tomcat 9.0.84 and Catalina.sh. Everything is correct. That's correct only. Why it is not finding it out?
Try to execute Catalina there individually. I think it should work anyways.
Yeah, of course, but my doubt is it should find, right? Why? Because we have the file over there at the exact location. Let me go with Catalina.sh. If not.
No, but it will definitely not find, right? Catalina.
Yeah, it is not finding. That is the main problem. So it should find it out, but why? What is the problem here? Let me check out with this, and if it is not finding out, then we will try another way. Okay, but it should find that over there. Okay. Every time there's a problem with this Docker file. I'll go with the. But there is a problem with the double quotations. Let me check out this.
Yes, that is the thing.
Now let me check out this. I will save it. Okay. Cat Docker file. Everything is good. Now Docker rm-f $docker ps-aq Docker rmi $docker images -aq. Everything is deleted. Docker build -t Tomcat version 1 dot. Let's build out. Now if I go with Docker images, we have the Tomcat version 1. Docker run -itd -name web app and -p 8080. This is the server port on port number 80 and Tomcat version 1. Docker ps. Now we have the container running. Now here you can see what is the meaning of this. So the meaning is if any user is trying to 0.0.0 means any internet user is trying to ping on the port number 8080 of the server, that will be forwarded to the container port 80. That is the meaning here. Now, if I try to ping on the port number 8080 of that server, what is the server? We are having the Ubuntu server. We are running on the Ubuntu server. Let me take the IP address of the Ubuntu server, public IP or else public DNS :8080. If I give this, we are not going to get any sort of response. So see here, the site cannot be reached. Why? Because the port number which we have mapped is not equivalent to the application port number that is running on the container. In container, we are running an application on the port number 8080, but here we are mapping the port number 80. So if the request sent to the container port 80, there is no application running on the port number 80. So now what I will do here is, let me remove this web app container, docker rm-f web app. Okay. Now I will recreate the web app on the port number 8080. Port number 8080, Tomcat version 1. Now if I refresh this, I need to get a response. Hold on. There you go. You got the response from the container. So that is how you have to provide the port numbers on the required configurations. So here we have provided, this is the server port and this is the container port. I hope you understand this. Now the next one here is, we have given the CMD. The main problem with the CMD is that whenever we are passing any argument at the time of, this argument is different, guys. Whenever we are passing any command argument at the time of creating the container, so those are the build arguments. So whatever you are seeing here, this is the build argument. Now whatever the argument that I am saying you here, this is the container runtime argument, which means at the time of creating the container. Now if you can see, what is the command it is executing? Look at here. The container is executing the command docker ps. The container is executing the command tomcat apache, or else if you want to know exactly the command which it is executing, docker inspect, the container name is web app. If I give this, look at there. If you see here, whenever I am inspecting the container, it is clearly stating that it is running the command. What is the command it is running? Yeah, there you go. Path Apache Tomcat. In this path, whatever the file is there, it is running that. So that is the command it is running. Okay, so this is the instruction. This is the command which inside the container it is running. Okay, so if I pass the build time command at the time of running the container, see here, docker run -itd -name web app. Okay, from the Tomcat version 1. Tomcat version 1 with the help of this image. And now what I am doing here is I am passing a command called as stress. When I pass this command called as stress, see here, web app is already there. Now I will go with web app 2. Now what happened? See there, error response. So unable to start the container process, execute stress, which means that, see, previously we have given the command, the path, whichever the path is there, we have provided that. Okay, so Tomcat /Tomcat and all the things we have there. But now if you see here, docker inspect, what is the container name? Web app 2. Previously when I inspect web app 1, it is having the CMD /Tomcat /Apache /bin /Catalina.sh. But now if you can see here, it is executing the command stress, which means that in the CMD, whenever you are running the container, if you pass any external argument on the CLI, that argument will be replaced with the container arguments. So whatever the container arguments that you are having, so what are the container arguments here? Catalina.sh, comma run. So these arguments will be replaced with the new argument which I have passed through the command line. So I have passed the command line, so that will be overridden. Okay, so this is the main problem with the CMD. So what is the problem with the CMD? When we are passing the external commands to the CMD, automatically whatever the main command that it should be executed, that will be overwritten by the new command. Okay, whatever the command that we have passed externally. So this is the problem with the CMD. Understood? Guys, what is the problem with the CMD? Do you understand this?
Yes.
Is there any questions?
No.
Okay, cool. Now to overcome this problem, what I will do here is I will go ahead with the entry point. There is an option called as entry point. So entry point will also do the same thing like CMD. But the main useful thing with the entry point is, for example, ping -c space 5, comma, I want to ping to Google. Okay, I will provide like this. This is not this. Okay, so if I run this 5 times, I want to ping to Google. So now what happens here? Let me check out. Nano Docker file, or else nano ping Docker. This is the file which I'm creating. Okay, let me save this, and Docker build -t ping version 1. This is the image name which I am creating from the file -f ping docker. Where is that? That is in the current directory. Okay, so now we have a ping file. Now I will create a container. Docker run -it -name ping container with the image ping version 1. Unable to know the ping command. I think ping is there or not. Yeah, ping is not installed. Let me do one thing. IP utils -ping. Okay, now if I execute this, let me go with the nano ping docker. Then it will be recreated. Why we want all these things? We don't want. I just want to show you what is the main problem with this. Let me remove all these things. This will take so much of time. Okay, I will remove this. I'll simply give this, or else you can remove the add command also. Add is also not required. Add is not required. If you want to delete the version or else anything. So let me give a small image. Why we want to go for a very big image? Nano ping docker. Let me save this. And cat ping docker. Okay. Docker build -t ping version 2 and -f ping docker dot. Good. What is there is an image unable to read -5. Okay. There is a problem with this. Let me check out this. Hold on. So what I can do here is ping -c5, which I can give so what I can do here is in spite of 5, I can give like this. Okay. I have given only Google nano docker file, so not the docker file. Nano ping docker. Of course, it is taking time, guys, but sorry. Ping docker here I have given only Google, so I have to provide a google.com. So I have to provide ping -c5. Okay, so now what I will do, okay, so I can give like this. Let me go with the ping google.com. -c5 means it will go with the 5 times of google.com, but I want to ping it for Yes, a pretty small amount of time. So how I can do this is -c5. Hold on. Let me go with the Google itself. That's more than enough. Let me copy this and let me build the file. Okay, so there is an error. What is the error? Unable to locate the package at google.com. So we have to go with the ping, but that's okay. So now let me do without ping. What I will do here is a nano docker, or else without going with the ping, just to explain you ping docker. Here I will give the apt install. So what I will do here is again, why we need to go with this apt install, apt comma install install comma -y and git. If I give this, it should install the git, right? So what I will do -y comma git. When I try to give it, it should install the git. So now I will build, let me go with the Docker. So what is the entry point given over there? We have to install the git, right? But here, what is going to happen here is, it is not going to install the git, or else we are getting this nano in Docker. Everything is fine. Let me save this. We are getting the error as ping apt install -y git. Everything is correct, but why ping Docker? Here I have to go ahead with this. Let me remove this and try to execute this. So previously we did not face any error like this, but that's okay. So now the point is, what is my intention to share you here is entry point will append the data, not overwriting the data in the CMD. So I just want to show you in the perfect format of this entry point apt -y apt install git. So this is what my requirement. Save this and let me recreate it again. But all if it is wrong, let me go back and check out this. Docker file apt install in CMD instruction. Okay. Here there is an option that is in the CMD we have to install. So this is a run command. Run is totally different. We don't want to run. We want to use the CMD. Okay, let me go with the run CMD. We need to get an example. What is this? Or else I can go with the Docker file CMD instruction. Executables param1 and param2. That is what we have done up to now. So here labels, everything is fine. I want the CMD. This is what we want. Apache -d executable. And now what is my requirement here is About the Docker file reference. CMD. Param1, param2, that is what we have given. Executable, comma, executable is apt install, and param1 is -y, and we have given with the git. Okay, this is absolutely fine. Let me remove this nano ping docker file. I will remove this particular braces and I will try to run this. Okay, without the braces also you can run. Let me go with save and for that let me find out the properties over there. Echo hello world executable. This is what we have given. Here we are facing the problem with the entry point. I did not complete it successfully. Hold on. Sorry about this. Hold on. Entry point install it. Okay. apt get update and apt install -y. This is what we have given. It's perfectly fine. The same we have given in the entry point also. Then why it is showing an error? Nano ping docker. Here we have given like this. Let me go ahead. ENTRY. Okay. So let me paste it over here and close it. Okay, the same we have given. Let me save this and let me create the image. Ping version 3 -f docker dot. So everything is the same we have given. So again we are getting an error. Command line option comma is not understood in the combination with the other options. Why? Is correct. So here also they have provided the same. See there? Comma y. It is same as it is. I go with this stack overflow. Run.sh. This is what they have given. Here also they did not provide the properly. Everything is correct here, but why we are getting this into one thing? Nano ping docker. So I won't go with this. I won't take much time. Let me do one thing. Git. Okay, if I go with this, what is going to happen? Let me check out this. Not accepting. But anyways, that's okay. We will check out this in the next session. What is the main problem with this? I don't find a problem with this Docker file, not the next session. Let me complete this only right here. What is the main problem it is causing? Apache Tomcat, and that's okay. This is not the file. I want to show you the main difference between CMD and command prompt, guys. Just hold on. Let me go with CMD to ping. Okay, in Docker file. Let me go with this. Hold on. IP utils ping. This is all good. This is not what my requirement. My requirement is CMD instruction. Instruction. Okay. Google.com is correct. Ping is correct. Everything is fine. But why it is not happening? So that is what we have provided also. We can see sometimes it is creating a very big mess. Okay. Everything is correct. By name, it's not my requirement. Okay, that's okay. So we can use, so the entry point is used to execute the commands. So if at all, if you are executing the commands, it will be appended. So simply you have to understand that. So I just want to show you and then I will terminate this session. Let me go back to weekend. Here, what I will do is, let me go to the Docker file. I just want to, if it is completed, then we can wind up the session. Entry point, ping c5, google.com. This is fine. Let me give a comma over here. Nano, ping docker. Let me save this and execute this. Come on. Nano. Previously, we didn't find the ping. Now it is finding the ping. What is a problem? Google.com. I will provide like this. Okay. Now, what I will do, I will try to generate the image again. It is again, there is a problem again. Okay, no problem. I will show you this particular entry point in the next session. Don't worry about this. This is also one of the alternative for the CMD. So in the CMD, whenever we are executing, the CMD instruction will be overwritten. The next one here is expose. What is the expose command? So if you want to create any Docker file, now whenever you are creating any Docker container, so here you can see if I go with the Docker images, let me create a container with the Docker images. So if you can see, we have a Docker image Tomcat version 1, right? So now RM, let me go with the creation of any container. Docker, Docker run -itd -- name of the container is web app 10 and web app 10 and with the help of Tomcat version 1. I am going to run the container with the image Tomcat version 1. So here you can see here we have a container created, that is, see that web app 10 is the container which has been created, but here there are no ports. So here you can see there is no port. What is the meaning of these ports? For example, you are the Docker administrator in your company. So you are the senior DevOps engineer and you know how to generate the Docker files and how to create the Docker files. Unfortunately, what happened is because of any reason you have went for a leave for 10 days. Okay, 10 days you went for a leave. Now there is a container that is running and your junior is there who has to manage those containers. when the junior is there and he is working on those containers and he doesn't know the application which is running on which port. So if the other person, if the normal humans has to understand this particular container. So here also we didn't have given any particular container port number. If I want to specify the port number, so on this particular port number, the container is running. So we will use the command called as expose. We will use the command called as expose Docker file. Let me copy the entire thing. Here we can use the command called as expose for expose. We are going to expose the port number 8080 so that the user will understand. This. Okay, the particular container is running on this particular port number, so that he will understand this. Okay. So now let me create the image again. So now what I will do here is that one. Archive Tomcat version 9.0.83. I'll paste it over here. Okay, good. So now what I will do here is let me copy this. Let me copy this and go back to my server. Here I will paste it out. Now what it is going to do, the expose command will only tell us this particular port is open. On this particular port, the application is open. Apart from this, it is not going to do anything. So expose instruction in a Docker file will help us to understand this particular port number is open. So now let me create the Docker build -t Tomcat version 2 from Docker file. Unknown instruction. Okay, sorry. Nano Docker file. Here we have the problem. Okay, good. Now let me save this and then I am going to create the Tomcat version 2. Okay, good. So this is how when we run this expose command. So if anybody asks you in interview, they will ask you what is the main difference between what is the main functionality of the expose command. So the answer is the expose command is only helpful for us to understand on which port the application is running. It is going to display the port number on which a particular application is running. Okay, so now hold on. So in the next session, we have to complete the Docker volumes and then we have to go ahead with the Docker swarm. So I don't know, in the next session also it might be 3.5 hours of time. Now it has been taken 3.5 hours of session. In the same manner, in the next session also you will have some 3.5 hour session. Okay, so that's all for today. We will meet in the next session, guys. Okay, so now we have a problem here. Nano Docker file. What is the problem? This is not required. Let me remove this. Let me remove this also. Terraform is not required. This file is not required. Okay, and the version number is, I will go with the 9.8.03. Let me save this. Hold on. So this is from my end, and that is the demos which I can provide you. And in the next class, it will be a enroll. Whoever has enrolled for the session, they are going to get the link. And I have already provided you the syllabus on which we are going to work it out. And then if you have any further questions, you can ask me regarding the content and as well as regarding your questions. Whatever the questions that you have, you can provide me your or else you can ask me the questions now. Go ahead. Next 10 minutes, you will have the questionnaire. Go ahead.
So we are closing the session now.
Yes, we are about to close the session by letting you know what is an expose command. So I will tell you about the expose command and then we will close it. Next, your questions.
So
Mhm.
one thing, like when we add
Mhm.
in Docker command web app 2,
Mhm.
and when we create Tomcat version 2, what is the major difference between that? Like in that one command we write it correct, web app 2, then Tomcat version 2 Docker build minus ITD and something. What is the major difference between writing two names?
What is something there? So ask me precisely. So what we have done, can you explain me in a precise manner so that I can tell you? Docker run -itd -name web app 2 with the Tomcat version 2. This is what you want to ask me, right?
Yes. So what is the major? What is the role of name and
See,
Tomcat?
hold on. You can give any image, that is not a mandatory thing. So, but the updated version is version 2. So that's the reason the updated image version is version 2. Previously, I'm having version 1. I might be adding some new commands in the version 2. So that is the reason I'm using the image version 2. Okay. And the next one is why I need to go for web app 2. Already web app is running. Already web app container is running in the Docker. So try to understand in this manner. If at all, if you are having a folder, inside the folder, you are having a file called as web app. Can you create the file with the same name? Can you create another file with the same name? Is it possible?
No.
Then what we have to do?
You create.
We have to give a another name. So that is what I have done over there.
Okay, got it.
Yeah. Okay. What it is saying, archive Apache Tomcat 8.03. 8.03 only, right? So it has to get that. So Apache, that's fine. That's okay. We will see in deep into the next session about the entry point. Only left is entry point and of course, expose command, it is not a very big command or else very big instruction. With that, we can complete the Docker images. And then we will go with the Docker volumes and a sample application. And with that application, we will try to learn how to create the Docker compose and the Docker swarm. With that, we will complete the Docker. So still in the next week, we have a couple of, I think it might take another 3 hours of session to complete the entire Docker. The first day, we will complete the Docker and the second day, we will go ahead with the Kubernetes. So the next week agenda is to at least we have to start the Kubernetes, and those who has enrolled for the session, they will get the updated link. So that's all from my end, guys. We will meet in the next session. Sorry about today's, like we have missed only a couple of things, that is entry point. I will let you know about this in the next session. So have a nice day and we'll meet in the next session. Okay. So any further queries?
No, thank you.
Very good. Any another? So who doesn't have any questions, they can leave the session. Who else have the questions, you can stop over there. Okay, so I don't think there are questions here. Okay, so tomorrow we will meet on Saturday at 9 o'clock. Have a nice day and bye.